Okay, so time for our first lesson. We're going to talk about angles, and this should be a relatively short review, but maybe some new information as well. We all know what angles are. We've seen them a lot in our study of math, especially geometry. So if I just draw an angle real quick, we talk about, two rays, something like this. Here we go. And then that angle has some measure in here. In algebra, and when we study angles, we often talk about them in a coordinate plane. So if we take a look at a grid here, we may have, our y-axis right here, something like this, and then our x-axis right here, and we should label those. Okay, there we go. So here's x, and here's y. In algebra, we will often talk about angles having two sides, an initial side and a terminal side. Initial meaning beginning and terminal meaning end. The initial side is always the positive x-axis. This is just when we study angles in algebra. You may have seen this before. So here's our initial side. And the terminal side is where that angle ends. When we measure an angle in algebra, we say if it's a positive angle, we measure counterclockwise from the initial side. And a negative angle just means measuring clockwise from the initial side. So if we had a 30-degree angle, it would look something like this. And we would say 30 degrees is right here. If we had a negative 30-degree angle, then it would be down here, and the angle would be negative 30, just meaning going the opposite direction. Cool? So important vocab words that you'll hear me say in class or as we're dealing with angles, we have the initial side, the positive x-axis, and the terminal side where that angle ends. Some more vocab, some more ideas here. Again, just to repeat, we have the initial side right here. The initial side being the positive x-axis. I should label my axes. Always label your axes. It's good practice. So here's x and here's y. The initial side being the positive x-axis always. As we look at the coordinate plane, you might think that there's only a few angles we can have. So we could have a 90-degree angle, which would be right here. Remember, positive, always going counterclockwise. 180 degrees, which would be right here. 270 degrees, which would land here. So here, let's review those. 90 would be there. 180 would be here. 270 would be here. 360 would be here. All the way around. And we could also measure those in the opposite direction and have different measures. So we could have negative 90. And notice that negative 90 ends in the same place that 270 ends. We could have negative 180 degrees. And that ends in the same place that 180 degrees ends. Or we could have negative 270. And that ends in the same place 90 ends. And then we have negative 360, which gets back to where we began. So in algebra, as we study angles, we talk mostly about where these angles end, the terminal side. And a lot of angles, as a result, can be what we call coterminal. So let me just get rid of all of those measurements real quick, and we'll talk about some coterminal angles. Co just meaning same, terminal meaning ending side. So if I draw, let's say, again, another 30-degree angle. So there we go, 30-degree angles. So in somewhere in here, right, we have 30 degrees, looks something like this. A coterminal angle would be any angle that begins at the initial side and ends at the same place this 30-degree angle ends. So it could do this. Go all the way around once and then go another 30 degrees. And so you're probably doing that math in your head. All the way around once would be 360 degrees. And then we add another 30 degrees. And that would be a 390-degree angle. Now ask any skateboarder or snowboarder, skier, 30 degrees and 390 degrees are not the same. If you turn 30 degrees on a snowboard, that is not the same as turning 390 degrees. The point, though, is if you turn 390 degrees, you would end up in the same place as turning 30 degrees. We could also have gone in the opposite direction, starting at the initial side, going in the negative direction this way, and then ending right here. So if I had gone in a full circle, that would have been negative 360. So you can see the way to find that angle would be negative 360 plus 30 degrees. And that angle there would have been negative 330 degrees. All three of those angles end in the same place. They have the same terminal side. We call those angles coterminal. But they are not the same value. They are obviously different numbers, just that they end in the same place. And if you are thinking critically here, it doesn't matter how many times you go around the circle. As long as you end in that same place, you have a coterminal angle. So we could talk about, 360 and then another 360, which is 720 plus 30. So that's 360 plus 360 plus 30. That's 720 plus 30, or 750. And if we start to list these angles out in order from largest to smallest, I have 750, I have 390, I have 30, and I have negative 330. You'll see an important relationship about coterminal angles. Coterminal angles. Coterminal angles are separated by 360 degrees. I can find larger angles than this by adding 360 and then add another 360, add another 360. Or I can find smaller coterminal angles than this by subtracting 360, subtracting 360. So big idea there. How do you find coterminal angles? You add and subtract multiples of 360. All right. One last idea. And that is, how do you measure an angle? I think in your previous study, you are familiar with angles being measured in degrees. And we can have any kind of measure of an angle, like, let me get a pen ready, like 30.5 degrees, right? You've probably seen that before, decimals or fractions. An idea you may not have seen is an idea that a lot of pilots and navigational people use. We think about the coordinate plane, and we think about this circle around the coordinate plane representing a clock or time. And so a lot of times, instead of saying 30.5 degrees, we'll divide the decimals up into minutes and seconds. So we may say 30 degrees, and then half of a degree being like an hour, we would say 30 degrees and 30 minutes. And I know that's a little strange, but just kind of go with me here. We can take a look at an angle, something like this. It's written, this is 132 degrees, 12 minutes, and 37 seconds. And we'll work on converting from what we call degrees, minutes, and seconds back to decimals later. But for now, I just want you to get this, that 1 degree equals 60 minutes. And I think you understand that 1 minute equals 60 seconds. So another skill that we're going to work on is just working with degrees, minutes, and seconds and finding complementary and supplementary angles. And I hope that those terms are review. Again, I know it's not great to bring back our geometry, but I love geometry, and we should remember that complementary angles, right? Complementary and then supplementary. Those, we need to remember that complementary means angles that add up to 90 degrees, right? And supplementary are angles that add up to 180 degrees. Couple ways to remember that. I've seen students say, oh, complementary, supplementary. If I put a line right here, that looks like a 90. And if I put a line right here, that looks like an 8 for 180. Okay, that works. Another idea is looking at the P's. And if you put a P in a mirror, it looks like a 9 or a Q, but it could be a 9. And so 2 P's, 2 90s, 180, or 1 P, 90. Again, that kind of relies on our ability to spell. If you can just remember comp, 1 P, and sup, 2 P's, that can help you remember that. So I don't want you to use your calculator, and it can actually be difficult to use your calculator with this, but in algebra, we're just going to go with complementary means add up to 90. So we can say 30 degrees and 60 degrees, but more importantly, we can say negative 30 degrees and 120 degrees. We can say that those are complementary because their sum would be 90. We didn't do that a lot in geometry, have negative angles. So in algebra, we'll do that. But complementary and supplementary. So part of your work in class tomorrow will be finding complementary angles and supplementary angles, but they'll be for angles that are measured in degrees, minutes, and seconds. So let's try an example. 63 degrees, 4 minutes, and 15 seconds. And I want us to find two angles with that. I want us to find the angle that is complementary to that and the angle that is supplementary to that. So 63 degrees, 4 minutes, and 15 seconds. Here's how we're going to work with that. With 63 degrees, 4 minutes, 15 seconds, and complementary, we'll take 90 degrees, and we will subtract 63 degrees, 4 minutes, and 15 seconds. We'll do this almost like we used to do subtraction a long time ago. We're going to borrow a degree. So I'm going to change this to an 89 because I'm going to borrow a degree, and that 1 degree is equal to 60 minutes. So I'm going to put the 60 minutes right here. Now I'm going to borrow a minute from that 60, and when I borrow a minute, I'm going to have a 59 minutes now. And when I borrow that minute, 1 minute is equal to 60 seconds. So I have a 60 seconds right here, and now I can do the subtraction. 60 seconds minus 15 seconds, that's 45 seconds. 59 minutes minus 4 minutes, that's 55 minutes. And 89 degrees minus 63 degrees, that's a 6 degree here, and 8 minus 6, that's 26. And so 26 degrees, 55 minutes, and 45 seconds. That angle is complementary to this one here. Complementary angles. Good? And we'll do the same thing when we do supplementary. So if I take this angle here and I find the supplementary angle, let's do that. Okay. So let me grab a marker here. We'll start the exact same way. we're going to say supplementary. That means 180 degrees. And we're going to subtract 63 degrees, 4 minutes, and 15 seconds. We can borrow the degree here and have a 179 and a 60 minutes. Borrow the minute there and have 60 seconds. 45 seconds, 55 minutes, and then 79, we've got a 6 here, and then 17 minus 6 is 116 degrees. Notice I'm being very deliberate with my units. This is a shorthand. I kind of glossed over minutes, seconds. I don't know why or how that was developed, but it's just a notation that is used. So there was a much easier way to find that, and I'm sure some of you thought of it. I could have actually just added 90 degrees to the 60 or 26, adding that to the 26 degrees, 55 minutes, and 45 seconds. That would have been much quicker, but I wanted to show you, depending on what you know, 180 degrees or 90 degrees, supplementary or complementary, what to do there. Sorry for the rough video. This is my first foray. I can't even speak. Foray? Is that the word? This is my first time really making videos for a class and explaining information. But come to class on Tuesday, ready to jump into this stuff, and have a great long weekend. Thanks very much. See you soon.